welcome back. Today we're going to talk about perpendicular lines. Perpendicular lines we know as two things that intersect at a 90-degree angle. And so a perpendicular bisector, the definition here in the first part is going to be a line or segment that is perpendicular to a segment and cuts it in half. And that's a true statement. That's saying we have something that cuts a segment in half, exactly in half, at a 90-degree angle. This is the symbol for perpendicular right here. It's an upside down T. Perpendicular. Perpendicular is what that is. And we have a couple of theorems that are associated with this. Theorem 4-1, 3-4-1. If two intersecting lines form a linear pair of congruent angles, then the lines are perpendicular. So here we go. We have angles 1 and 2. Angles 1 and angle 2 are a linear pair because they form a line. They're a linear pair. And we're also saying angle 1 and angle 2 are congruent, as marked. And so if the measure of angle 1 plus the measure of angle 2 is equal to 180, and the measure of angle 1 equals the measure of angle 2, then 2 times the measure of angle 1 equals 180. Well, that must mean that the measure of angle 1 is equal to 90. Well, if the measure of angle 1 is equal to 90, then that means it's equal to the measure of angle 2. It makes sense. If there's 180 degrees to be had, and it's divided in 2, and they're both equal, they must be 90. Next theorem. The perpendicular transversal theorem. In a plane, if a transversal is perpendicular to one of two parallel lines, that would be N and P in this case. So they're parallel. And angle Q, or line Q, is the transversal. It's perpendicular to line N, then it's perpendicular to the other line because I'm all about the because. Because in parallel lines, corresponding angles are congruent. Angle 1 is congruent to angle 2. Well, if angle 1 equals, the measure of angle 1 equals 90, then measure of angle 2 equals 90 degrees. Therefore, P is perpendicular to Q, because that's the definition of perpendicular. Intersects at a 90-degree angle. That's pretty much it. Theorem 3-4-3 goes the other way. If two coplanar lines are perpendicular to the same line, then the two lines are parallel to each other. So once again, I'm going to label these 1 and 2 because the measure of angle 1 equals the measure of angle 2. That means corresponding angles are congruent. Therefore, that's the 3 dots. They mean therefore. These 3 dots do. 3 dots in a triangle means therefore. Therefore, because corresponding angles are congruent, R is parallel to S by the converse of the corresponding angles theorem. So notice how all of these theorems that we've been talking about are coming back and playing into these new theorems. So because the two corresponding angles are congruent, that means its lines must be parallel. They just happen to be 90 degrees each. We've got a couple of proofs down here. We're going to work on those in class. And so that's the basics of perpendicular lines. Thanks for watching, guys. We'll see you next time.